We are only halfway to our goal of getting rid of global variables. In the last module we discovered how that we can get values into a function by using function parameters, and in this module we learn the other half of the equation, how to get values back out of a function. We do that by creating functions that can return a value. Now this is a little different from function parameters in that functions can only return one value. Doesn't matter what function we write, you can only get one value out of it. Actually, you can only get one value out of a function using a return value, but we're going to learn some techniques later that will allow us to actually get other values out of a function using other methods. Anyway, let's move on and discover about return values. Okay, so we need to know that every function that we write can return a value if we want it to. Now that includes main. Main is the only function that we've been creating in every program that we've written, and it's even true that main can return a value. Doesn't make a lot of sense really when you think about it. Where would main return its value to? But there is actually a place where main can return its value to, and we'll learn about that in a later module. In this module we'll learn about the extra functions that we write, in other words not main. We'll call those functions, and once we finish calling those functions will give us a value back again. We can think of that value as the result of the function if we want to. We've actually already seen an example of this. We have used a function that returns a value to us. Strillen is the classic example of that. We pass it a string and it passes us back a value which is the length of that string. Now the value that we get back does not have to be an integer. It could be a collection of different function return types, including a char or a float or a double or even an array. And we've also used functions that do not return a value, like printf. With printf we just call the function, we pass it the parameters that we want to pass it, and it goes and does its job, but it does not give us any information back again. Okay, so now before we can actually go about coding this, we have to actually get some terminology right. We say that the function has a type, just like a variable has a type. When you declare a variable, you declare it to have a type of, say, integer, or float, or double, or char, or anything you like. Well, it works exactly the same way with functions. When you declare a function, you also have to specify the type of the function. And so we end up with things like integer functions, and double functions, and float functions, and char functions, and so on. So the function, to say that the function has a type, says that the function's return value has that type. Or to put it another way, that will be the type of the value that you get back from the function. So let's have a look at an example of what that might look like. If we wanted a function that returns a value, we might write it like this. This is a very simple function that adds two numbers together, those two numbers being the parameters that the function is passed. Now the first thing that happens is that a result is created within the function. This is a local variable called result. And result obviously becomes the sum of the two numbers. Then, and that's the crucial step in the process, we use the keyword return, and then we specify the value that we're going to return, which would be in this case result. By using the word return, we are actually causing the value that is stored in result to get passed back to the calling function, say main or wherever we called it from. So how might we call this function? What would it look like if we actually were to call add from main? Well, it might look like this. We might say z equals add, and then the two parameters we might pass in may be x and y, for example. X will get copied into n1, y will get copied into n2, then we declare a local variable called result. We add n1 and n2 together, which would obviously be the x and y together, and then the return statement is called, which ends up passing the value back into z. Now we'll go and have a look at some code in relating to all of this. There's a couple of things we need to keep in mind before we do. The first is that the value to the right of the keyword return, in other words where we saw result there, must be of the same type as the function itself. In other words, if the function is returning an integer, then the value to the right of the keyword return must also be an integer, or in this particular example, the variable, the local variable called result, must be of type integer. Now you might have noticed that the function that we created there was nowhere actually that you saw in that source code that specified that the function add returned an integer. So what happens in circumstances like that is that the function is taken to return an integer by default. If you don't specify what the return value type of a function is, it's taken to be an integer. And when we look at the source code, I'll show you how to specify the type of a function if you don't want it to be an integer. Let's go and have a look at all of that right now. So this is average3.c, which is just a duplicate of average2.c, but now we're going to try and achieve our goal of getting rid of all of the global variables. There's only one left, and that's this one here, which, if you like, is the result of the calculation done inside this function here. So it's not too difficult a matter to get this last global variable out of the equation. Let's have a look at how we do that. Well, the first thing we need to do is we need to say that this function here returns a value. So what value is it going to return? Well, it's probably going to return av, like so. Now, I don't want av to be a global variable, so I'll just cut that out of there, and I'll actually paste it into here. So I'll now make it a local variable. So this function's almost complete now. We declare it a local variable, we work out what its value is going to be, and then we return it. There's only one step left to do, and that is to actually specify that this function returns a float. It's not returning an integer. Or rather, as the code stands right now, it is looking like it is going to return an integer because we haven't specified otherwise. But we need to specify otherwise because this av right here, which is what we end up returning, is in fact a float. We return it here, and remember we said that the return type of a function has to be exactly the same as that which is to the right of the word return, which is here. So we must make average specified to return a float. So this is how you do it. You go to the beginning of the line and you type in float like that. So as you can see, declaring a function to be of type float is pretty much exactly the same as declaring a variable to be of type float. You just put the word float at the beginning of the line. Similarly, we could have just created this as an integer like that, and that would declare that this function is returning an integer. But as I said before, if you leave it out entirely, the function is taken to return an integer by default. Anyway, we do need the float here. Okay, so that's now the average function is complete. However, the program will not compile yet because down in here, right here in the printf statement, we are referring to a variable that is no longer a global variable. In other words, we no longer have access to the variable called av. So what we have to do is we actually have to create another little local variable in here, and let's call it, that's going to be a float, and we'll call it we'll call it the same thing. We'll call it av as well. And this is how we actually receive the return value from the function called average. We type in av equals whatever the function returns to us. So now when the function called average is run, it will actually put its result into here, which is just a little local variable which we will then print out right here. So it's probably time to see whether the function will actually compile and run. So let's try that. Okay, it compiles and it runs. Yes, it does. So 23, 45, 21, and we get an average that looks pretty much right. Okay, so we've successfully gotten rid of all of our global variables, but I'd actually like to take this one step further. I'd like to see if we can't actually achieve our original goal, which is to have all of the input stuff in one function, all of the output stuff in another function, and the calculation in a third function. Now we've already got the calculation bit done, but I'd like to get this into its own function and this into its own function. You think we can do that? Well, let's give it a go. The first thing I'm going to do is I'm going to take all of this code out of here, and I'm going to create another function up here called input. like so. And then I'll paste that code in. And then you would probably want to do something like this. Return. Now we're presented with a bit of a problem. We're actually wanting to return 3 different values, but we find that with the return function we can only return 1 value at a time. So how are we going to get around this? There's absolutely no way that this input function can return 3 different values. So what I'm going to do is I'm actually going to rewrite the input function a little bit such that it only asks for 1 number, and it only reads in 1 number, and it only returns 1 number, and then we're going to call the input function 3 times, which will have the added bonus of cutting down some duplicated code. You can see a great deal of this here is duplicated code. So let's do that. Let's get rid of all of that. And rather than saying please enter the first number, I'll just say please enter a number. And we'll call that num. So we're going to need to create ourselves a little local variable called num. Like so. And then obviously we're going to return num. Now, do we need to specify what type of the function it is? Well, we could say that it is an int function. We might as well. It's nice to be explicit every now and again. This function is going to return an integer, and there it is. So now we need to call it 3 times. We need to say that num1 is the result of calling input the first time, and then essentially the same stuff again. And num3 finally equals input all over again. And then we average them out. Okay, you can see what I'm getting up to here, so let's try and do the same sort of thing with this function here. I'll create an output function, and we actually have to pass the output function a value. The value that we have to pass it is the average that we want to print. So we'll pass it a float called, say, A. We'll call it A this time, so we'll make this A. And this doesn't need to return anything, because all it needs to do is print something out. So now we go down to here and we simply say output. And we need to pass it in a value. We need to pass it in the average that got calculated, so we pass it in AVE, which is like that, and we're in business. Okay, so let's compile that. And it compiles okay, which is a good sign. And we'll enter a number, 23, 78, and 1, and the average is 37. Okay, well that looks about right. So it's clearly working. But now we don't have that message, please enter the first number, please enter the second number, please enter the third number. Now I know that's not particularly important, but I'd like to put it in just for the sake of it. So we need to make a modification to our input function. This is just a bit of practice on using function parameters. It's also a bit of practice on using the switch statement. So we'll put in here a little number saying which do they actually prefer. Which number are we actually trying to read in from the keyboard? The first one, the second one, or the third one? And then what I'll do is I'll create a little switch statement. So we get a little bit of practice using switch here. And I'll switch on that particular sequence that they gave us. And if they gave us a 1, then I will do a strcpy of, well, I'll strcpy into a little string, which I'll create in a second, and I'll just put in there first. And notice that I always have to put a break after each case, so I'll just put the break right here. And then I'll just duplicate that line, change that 1 to a 2, change that 1 to a 3, like so, and then I can say third there, and I can say second there. Now I'll just actually have to go and create that string now, position, and how big do we need it to be? Well, we're only ever going to put 6 letters plus a blank in there, so that's 7. Make it 10 just to be on the safe side. Okay, so now we can do it like this. Please enter the something number. So then we can simply say like that. Now, depending on what function parameter is passed into input, whether we get passed a 1 or 2 or a 3, we'll actually say please enter the first number, or please enter the second number, or please enter the third number. So now obviously we actually have to go down into main and call input differently for each one of the three. So that'll be simply a 1, a 2, and a 3. Let's see if that compiles. Okay, no errors, and run. Please enter the first number. Okay, so it seems to be working. 12, 45, and 34. And there's my average. Okay, very nice. So this is not a bad little example. We now have no more global variables. We have a function here that takes one parameter and returns one integer. We have a function that takes 3 integers and returns one float. And we have a function float and returns nothing at all. Mind you, we also have main, which takes no parameters, and well, it's returning an integer, except that we're not actually specifying anywhere that we are returning an integer. But even if we don't specify it, main is still defined to be an integer function, by default of course. So this is not a badly designed program now. No global variables, and we have an input phase, a calculation phase, and an output phase. So in other words, we have 3 small and simple chunks. We have an input chunk, a calculation chunk, and an output chunk, as you can see. We'll now try and achieve the same results with our striln.c and also with our little file called double.c. This is striln2.c, which is just striln.c resaved as striln2.c. So let's try and get rid of this particular global variable. Okay, so the first thing is to make strilength return a value. So we'll return a value here. Let's not call this length. Let's call this just something like I. Little loop counter, little local variable called I. So we've got to actually create the local variable, which will be simply an integer, like so. And then we'll return I as our return value. Now this global variable up here, we'll actually turn that into a local variable inside main. And this is how we'll do it. Now, we'll still call strilength in the same way. We'll still pass it the string, but we're actually going to get a value back now. So we actually have to put something on the left-hand side of an equal sign here. So this is where we'll use length. And theoretically, that makes our program correct. So what I'll do actually now is the little strilength function, I'll actually call it twice. So I'll duplicate all this code down here, and instead of creating our first name, I'll create our last name. So please enter your last name there, and the length of your last name, and so on. So we'll be doing exactly the same thing twice. I just want to prove that we'll be able to call strilength with 2 different values and get back 2 different results. Now before we compile that, we're going to run into a little bit of trouble here with the scanf. So I'll just insert some text. I'll put a little f-flush in there so that we don't run into our standard scanf problem. And let's try and compile that. Compiles and run it. Please enter your first name, Mark. Please enter your last name, Virtue, and it seems to be working beautifully. Again, the same sort of thing with this doublet function. This is now, which I'm just modify in such a way that it actually works. If you recall, doublet here will perform a doubling operation on the number, but what gets displayed is just the original number. The number does not appear to be doubled. So now we can actually make that work. Now we're going to call a return value here. We're going to return something. Well, we could just return N1. That's perfectly possible to do that. But I'd just like to temporarily return something called result. So we need to declare an integer called result, like so, and then we can say result equals N1 times 2, like so. And then back down in the main, where we actually call doublet, we need to specify again some kind of answer. So we can do, say, answer, which would be an int, and then we can say answer equals the doublet, and the doublet value is answer. Now, all of that's going to work, but what I'd like to do is just a little bit of cleverness to make the code a little bit simpler. We don't actually need to have a separate local variable here. In fact, what I can do is I can take that n1 times 2 and put it here just to the right of the word return, which means that the doublet function becomes very, very simple. Yes, it is possible to have a calculation on the right-hand side of the word return. That's perfectly acceptable. Now, I'm going to be even more clever, and I'm going to take this entire function here and take it away from there and put it in place of the word answer. Now, of course, if you recall, answer was just equal to whatever this function here returns. So it is perfectly acceptable to replace the word answer there with the actual function call itself, which means we no longer need that line, which means we no longer need that. Our program is now considerably simpler. Less lines of code, more efficient, runs a little bit faster, and yet does exactly the same thing with no sacrifice in readability. So let's try and compile it. Obviously the proof of the pudding is whether it actually runs. And let's try entering a number like 12. The doubled value is 24, so that is indeed working. So there's 3 very useful examples on functions that return values.